Laurence Stonard. I'm the workshop manager in the OTC, which is the Old Teachers College in Sydney University. Today I'm going to be talking about drilling a hole, hand tools, and then we're going to go on to a pillar drill. So there are various things that you should be aware of when you're drilling a hole. The predominant thing is the safety. So I don't wear gloves, I don't want my hands to get caught entangled into the machinery. If I'm doing something that's dusty, I'll wear a P2 face mask. If it's very noisy, I might wear some hearing protection like these earmuffs, or I might use some plugs which are disposable. You just put them in your ear, use them for a couple of hours, throw them away, don't contaminate. Now, I'm a spectacle wearer, and because I wear glasses, I'm not protected from splinters or swoof or something coming into my eye. If a tool breaks, it could damage my eyesight. So I have to wear safety spectacles. And these are protected, they're polycarbonate, so if something hits it, they won't break and shatter into my eye. So today I'm going to mount this up in a woodworking vise. It's a piece of plywood. So I'm going to mount it up in the vise. I'm going to put a small drill in, and I'm going to drill a hole using this electric battery-powered drill. This little drill here is about 6 millimeters diameter. It's called a jobber, which is a type of drill. So I tighten that up. I place it on the job. I try and get it square, and then I've drilled a hole. So that's a normal jobber drill, jobbing drill. This one is a center drill. This one is used for starting off the hole. So I would use this if I was drilling into metal or I wanted to get an accurate hole. So I can put that on there and start drilling, and that will start a hole ready for me to drill down with the next drill. So this drill is what's known as a pilot drill, and pilot drills are used, so this is a tungsten carbide tipped hole saw, and that has a pilot drill on the beginning. So the pilot drill goes in and starts the hole off, and then it keeps the hole saw in the center position. So this one's tungsten carbide. This one is high-speed steel, so this is used for timber. This one is used for timber, plastics, metal, so it has various uses. This one is usually timber and plastics. This one is a forester bit. This is a specialized tool. This is used in cabinet making. This one is a stepper drill, so it has different steps of different diameters. So should I be drilling into a thin piece of steel, if I used a normal drill of a larger diameter, as it broke through the surface, it would try and pull it up. With a stepper drill, it allows me to go up in steps, so I drill a hole, and because there's a little angle between each step, it acts as a countersink, so I get rid of the burr that's formed around the hole. So if I was drilling metal, I would mark it out, I would take a center punch, put it on my lines, get a hammer and hit it, and I would make a mark in the surface. So then when I start to drill, the drill will automatically find that hole and it will be piloted in to my job to drill it. So if I don't want to slide off the surface or I'm drilling into a radius, then I can use the center punch and a small pilot drill to start off. So this drill here is called a reduced shank drill. So that's the machine shank. So on here I have a chuck which has a 1 millimeter to 13 millimeter capacity, and obviously that drill is more than 13 millimeters and I can't get it into the chuck. So this one has a special reduced shank, so I can put this drill into here. Bearing in mind, this is doing a lot more work, and if your tool isn't very good, you'll damage the tool by using this size bit. So normally, a reduced shank drill is used in this machine that I have behind me, which is an electric motor driven with a reduction gear in it. So we're going to come and have a look at that machine, and I'm going to drill a hole in that machine. This is known as a pillar drill. You can get bench mounted machines but this one's bolted to the floor. It has a table that can go up and down. It has a handle that has the feed, and this is the quill, and attached to the quill is a chuck, and in the chuck I have a drill. This is the table, and it has holes in it for clamping down. Inside the machine there are 3 pulleys. There's a 3-phase motor on the back here which drives this combination of pulleys, and I have a speed range from nearly 5,000 revs a minute down to 144 revs a minute. So depending on where I put these is the speed that I can get for the drill. So the speed is related to the size of the drill and the type of material that I'm cutting. So all of these operations, me showing you this, was done with the power turned off. I'm now going to turn the power on. So now the machine is energized, the light comes on so I can see the work area. So when I set the table up here, I just run the drill through and make certain that it goes down the hole in the center of the table. And the reason for this is I don't want to drill holes in the table. So what we normally do is get a scrap piece of timber and you put this on the table, and then when you drill through your job and you drill into this, which is the sacrificial piece of timber. The reason for having it underneath there, if I just had the hole underneath there and I drilled through, as the drill comes through, it will burst out the material and pull it away. So by me putting it on there and drilling through, when I break through, the drill will start drilling into here and it won't damage the timber underneath. So there are various ways that you can do this. Now I've got a long piece of timber, so I've got a mechanical advantage, so I can hold on to this. I don't wear gloves. I'm not doing anything that's going to get caught in the machine. So this is the chuck key. I put the drill in and check that it's tight. There's a switch on here so I can turn the machine on, and then I can operate the handle, and then I come down and drill into the work. I can stop that. So there we are, I've drilled through and I got a nice clean hole on the other side. The advantage of using this is that there's a lot more power in the machine. I can adjust the speeds and it gives everything square. So the table is square to the quill and the drill comes through, and so I get nice square holes going through the timber. So if I don't want to use this piece of sacrificial timber, I can set up a clamp on the table. So that unscrews, comes through the table, and then I can clamp it down, and then that will hold it while I'm drilling. Or I can put the timber in a vise and hold it. I just lowered the table down there. So okay, that was me drilling a hole in a piece of timber. It's a demonstration of the pillar drill. Once again, my name is Laurence, and you've been watching a video that was made at Sydney University to show you the basics of drilling.